Hello and welcome back to the second part of the video uh, of showing the NTT program. And this section of the video, we will be discussing about how to run the NTT, and they will be giving an example and then follow it for you to see how the key points and key functions are in NTT. And so if you need to know about NTT itself, please refer to the previous video that I have recorded for you, and that's the NTT general description video. And this screen shows that how, as you get into the NTT, you will see the screen that welcoming you, and this is a place for you to sign in. And if you don't have a previous account, you can create one and just get to some information, and we will have your account set up for you on the cloud, and we will keep all your projects just for you and to get access to in your account. Before I go there, I'd like to tell you some stuff about NTT again. If you want to know about NTT in a very short term, short statement, you will just push that button, and if you're done with it, you just completely shut it down. And what's new is going to talk about what we're going to be doing in the future, coming very early future, near future for you on NTT. And also in the video that we are going to be watching is under this button, and then you can contact us. And depending what version you use, you will be contacting additional person for that is in the available for help to you. And other programs that we talk about here, related tools, is a SEOD program, SEOD is a program that deals with the watershed, that combines economic, environmental models and evaluate management practices at different scale. And then the NTT is going to be the second type version of the current one that I'm going to be talking about, that you can get access through this. And NTT G2 is going to be the last version that we had available for you. So those are available as kind of related model to this one. So that being said, let's go ahead and I'm going to go ahead, and I do have an account, so I'm going to just go ahead and use my sign-in information. My user name is going to be my email there. And my password is going to be this, and I'm going to sign in. So once I sign in, as you will be doing the same thing, you will see the list of all the projects that I have dealt with as testing the program, and others that have helped me to do so. So in here I have a number of options. The option is that first one, I can create a new project from the scratch, upload a project and that I have previously saved, and upload example file so I can see how it works. But nevertheless, if you have created a project like I have or others done, you will have a number of options here. One is that you can save your project beside on the clouds. You can save that project and put it on your hard drive, and then you can get back to it anytime you want to. And that's where you upload the project. And if you don't want to be on the cloud, you just basically delete it from the cloud, but you will save before you do that. The other thing is that you can use this pen to change the name of project if you wish and rename it. But the very nice function here is this, that you can copy and duplicate basically your project, so you do not if you do change something that you don't want to change, you can always have the original copy for you. So those are all going to be available only for you on the cloud on your account. So that being said, let's go ahead and start a new project. I would like to start a new project. That's what I'm going to do. And then to do so, I just say create a new project. It's going to ask me project name. Let's say we're just going to say tier project. And project description, this is optional. I want to say this is a demo. So by just doing that, I save this, and it's going to take me to the map of United States. And also, as I said, we have done work on Puerto Rico, so this map is going to be also showing the Puerto Rico as part of the interest here. We haven't done anything on this side yet, so that's not functional. So this is the part. So getting that, there are many ways to kind of get to the area of interest, where your farm, your watershed, your field, or whatever it is there. You can use the this function. Option 1 is the shapefile. If you have a shapefile of your farm, you basically, what it is on the area of interest, you can upload it and it's going to go right into it. And in the case you have a watershed, then, or the farm that has multiple fields and you have a shapefile, this is an option to do. Then the second option is going to be using the mapping system, meaning that the to get to the area of interest, you can say through the address. If you type your address, you will get there. You can put the latitude, longitude in there, and it will get you also to that area. And also you could do state and county, which I'm going to use that function. So I'm going to say, I'm going to go to state of, let's say Ohio in this case, and I'm going to go ahead and say, so this took me to the Ohio, and I'm going to say the county, I'm going to do let's say Carroll County. So it just zoomed that area. Also, you can use the mouse here with the negative, positive, and zoom into anywhere you want to. So so I'm going to go ahead and get closer to where I want. So you can zoom into very precise, as Google allow you to do. And let's say I was going to pick up a farm. This is as my farm. So what I have to do now, if I select this farm, I just do click on this site and give the area. So that gives me a farm that I would say one farm, one field. Basically, I can select different fields and then all be connected or separate. If the producer is buying different land in different area and it's closest the vicinity, it does allow this, the entity allow you to do so. So I'm just going to say farm, which I'm not going to have another field. In the next video, we will be talking about the watershed function of this functionality of this NTT program. So I say farm, and then it just basically it colored it for me and it says the name of that field, which is farm. So if I am done with this and I'm not anything else, I don't want to select any other land, I just say submit. And what it does, it goes and picks up the weather file and the soil information. At the same time, it's going to give me the area that I selected. My farm is 26.15 of acre, and so the only option I have is to delete this. Well, before we continue, from here on, there is going to be a little bit of difference between the RE version and the basic version. So we are in RE, research in education version. So it's kind of comprehensive of everything that is NTT provides. But however, I will talk about those issues and the differences as we go along. And not much, but there are some, but I will talk about that. So the next step is that I'm going to go to the farm, and then all you have to do, click on it. And once you click on that, it's going to bring up the soils and the weather for me. Like as I said, in each field at least it picks maximum picks up 3 soils that they measure, and it adjusts it for you to become 100% of your farm, the area. So in this case, I have the soils that I have here, they're all well drained, so there is no need for drainage. And one thing else I can do here, which is not available in the basic version, is this button. I can go there and use this button for soil number 1, and I can get access to all the layers. And when I get access to the layers, I can modify any of these parameters that is related to that soil. These parameters are being gone through a lot of sensitivity analysis, and we find that these are the most sensitive to Apex program to simulate. So when we go here, it gives us some general information, and if you want to have a modification, that's why the researchers, they wanted to do, and they can do. But one thing is in a common in both versions is the soil P test. So if you have any soil P test, you can put in the value from what laboratory methodology you used, and we convert it to malloc tree, which is going to be the values for the apex, and we input it as the apex in the soil file. So if you have any of those, then you put a value for it. You can change bulk density, sand, silt, clay. So this portion, except the soil P, is not available in the basic version, which we understand producer relies on the soil survey, and they doesn't need to do this unless they have their own survey. They can come to this version. So the next thing is going to go back to so you can do for each layers, but the soil P in the basic version is only, it will be done for you for the top 6 inch, and once you put the value, we assuming that's where your sampling is going to happen. So from there, the other thing is not available in the basic version, the weather information. Again, these are important for the researchers. So let's say, for example, you have your own weather file that you can upload from using this button, and then we show you how in the help to create the weather file for it, and then you just upload it. If you have the research plots that you have the weather file, this is the way to do it. The other thing is we can do is going to specific coordinates. We can take the weather, for example, from New York City, apply in El Paso, Texas, to see what happens if that weather one day moved there. And also you can change the date you want to simulate. We will give you what was the available dates on the weather we generated from the prism data for that location that you are, but you can change the year of simulation. And in this case, if somebody has the weather station that they have done 4 or 5 years, then they would just upload the weather and then adjust these years of simulation. And anything less than 10 years, 12 years, we add 5 years as warm up for the model. Model needs to warm up. So if you're doing from 2010 to 15, we will have another 7 years automatically added and simulate for you to warm up the model. So once finished with the weather, then it's going to jump into the management. This is where the major part of the user's inputs come to play. Means that you need to go ahead and put the management practices, and this is where you do the scenarios and then your alternatives and see what happens if I do this, if I do that, this is where you're going to show up a lot of inputs there. So to create a new scenarios, and if you had other scenarios created for other fields, if you have multiple fields, you can bring it here with this function. But at this time, we're just going to have to create a new scenarios. So the first thing is going to ask you is what is the name of scenario? I'm going to say baseline, let's say corn. I'm just going to use corn as my scenario name. So once I save this, it's going to ask you to take you to operation screen. This version, comparing to the last version, is this that we don't have all the rotation. If you look in this NRCS, the management files in their system, they have thousands of based in the zones, thousands of management practices that rotation. But it's sort of confusing because we don't know if that's happening today and what combination the user wants to use based on change in the weather and the market, so on. So what we have done here, we created a list of the major crops that's available to you in that area of interest which the model pops up. So if you are again in California, different crops. If you come to Ohio, different crops. Based on what's the major cropping system is in the area, it pops up for you as a default. So in this case, let's say I do want to have corn, and so you can do a rotation by selecting individual crops and then putting the years of rotation, and the model generate for you a management file that we send to the Apex for simulation. So in this case it's corn, and I would say it would ask you, what is this? Is this a sort of intensive, high tillage or low tillage or no tillage? These are options that gives you, but again you can modify anytime you want to. So I would say in this case no till, and the year one, so it's upload for me. So what happened here now, I have a corn that is my first year rotation, and if I click on the plus side, I will see what operation as a default has been given to me. So I have planted on May 5th and applied, the seeding is 0.93, which is about 10 seeds per square, 9 seeds per square meter. But these are units per feet, square feet. So you know how much is an acre, you can convert it to a square feet. And also gave me the fertilizer that I done element N and 180 pounds on April 15 before planting, and then also applied 60 pounds of phosphorus on the same date. The other issues that we have here is the harvest time is going to be the year one, the October 10th. And then end of season means that I'm getting rid of the crop, and basically on this next day, that means there's just the residue left, the crop is gone, so there's no regrowth of that crop anymore. So any of this additional, the buttons here that you see, you can add, for example, fertilizer operation, you can delete them, you can modify them, and so on. So let's look at some of those. For example, on the planting, I did a no-till planter. You can change that. I can change the date and type of planting, and the seed, the numbers per square feet. Look at this. I can do fertilizer. This is fertilizer operation, and then the crop type, the date I have done here, and also I can say is a commercial fertilizer, or it could be a manure. If it is manure, is it solid manure or is it liquid manure? Let's just look at the commercial fertilizer, the choices. The choices are major are of fertilizer that's sold in the market. We have made it available for you. All you have to do is just say what form it is, and then we tell us how much, and we calculate for you how much nitrogen and phosphorus you apply. The other thing is that if you go with solid manure, then the screen change and it tells you where is this solid manure come from. Is it from beef, dairy, goat, horse, and so on. And so if you select beef, for example, then it will tell you what would be the amount of nitrogen per tons of that solid manure. And the only thing is also you have to modify this number and making sure the rate is now tons per acre, because that's how you apply. And also tell us what would be the moisture content of manure. We give you a default value, but we don't know what stage of manure you applied, so you have to give us some sort of idea of what would be the moisture content that when you apply the manure. And if you are incorporating, this is the where you put the depth, to what depth you're incorporating both fertilizer and manure, commercial fertilizer and manure. So, but if you have a liquid manure, then the screen change again, and this one is going to be concentration pounds per 1,000 gallons. And we know moisture content, if I select, for example, beef, is much higher. It's about 91% moisture content. So, and we give you the content as a start point. If you agree with it, you can accept. If not, you can put your own value and get the solid manure. So this is the way to put the nutrients, either the manure or commercial fertilizer, in your field. So one thing is, when you apply manure, make sure you're not applying any more phosphorus, because there's no need, because there's quite a few amount of phosphorus in the manure. So I go back without changing anything. So I still have 180 pounds of the commercial fertilizer, which is in this case pure N, and the element P, which is basically pure P. So with that, I have created a crop rotation. I can add soybean, I can add wheat, I can add many things. I can add cover crop. So if I was going to put a cover crop on this field at the end of the year, all it's going to ask you what is the type of vegetation you are putting as a cover crop, and then it's going to ask you what of course year one, and what is the date you put in on. So the model automatically creates a management file that you are going to put in the cover crop after corn until the next year comes up when you plant again. So this is going to be a BMP, or best management practices, that you're going to be applying in this field. And also asking for methods of so I don't want to do any of them right now, just showing you how I can do it. So then other one is going to be continue on this. I'm going to go back to this page and describe what is this page about. A lot of those nutrient management, tillage operation, those kind of management that you do, is we call it is a soft management or cultural management, but that can be done on the last page. But in this page there are some constructional managements. Now you build something in the field that is going to be mostly permanent in most time, that you want to do use this page for. So the first thing you see is auto fertigation and auto irrigation. There are two ways to put in this program your irrigation. One is manual, then you go ahead and put the date you applied, water and how much you applied. You go back to that last page, which is going to tell you as one of the operations you can add to it. It would be add the new operation, which is going to be irrigation. But if you are, that would be good if you are doing the research you'd have done 3-4 years and you know exactly what you've done, and you want to use this program to evaluate the experimental plot. But for most use that we're doing here is going to be using this function. But the Apex is a smart program. it looks at some factors that you put as the input, and based on that does the auto irrigation or auto fertigation. Let's look at those factors. So I'm going to go with auto irrigation. First question is going to ask you, what is the type of irrigation you do? Sprinkler, furrow, drip, and so on. So if you select, for example, a sprinkler, then it will come and say you there is efficiency to this system. And many cases this could be used for evaluating the irrigation efficiency and how that affects the crop production and how that affects the water quality. And so by improving it, maybe you get optimize your yield and so on. So this is a way to evaluate that, but typically it's about 70% in for sprinkler irrigation efficiency. The second thing is going to ask you is how often you can do the irrigation. In many cases, not everybody can do everyday irrigation. They have to wait for a few days to do that. So this is the day you set up. And if you are able to do everyday irrigation, you set this as 1. So the next thing is going to be plant water stress factor. It means that at 100% there is no stress. So you can irrigate anytime. The soil water and for plant is going to lower than the field capacity. But if it is 20%, you are allowed to go 20%, 80%, you are allowed to go 20% reduction in the stress level actually in the plant and the water in the soil. So this is the way you set it up. Again, at 100% you can irrigate anytime. So also you will be limited to how much water you can apply. If you don't have any limit, you set this number to high number. But nevertheless, these are the break points that control your management, that control your irrigation management. But if you do have a fertigation, then the only thing is going to be added is going to be the concentration of nitrogen in the water that you apply to irrigation. And if you do that, you be careful not to put anything on the fertilizer or maybe minimize it because you apply nitrogen through this to the plant. One thing is here, if you set this as 0 and you turn the auto fertigation, the model looks at as a deficiency of nitrogen in your plant and applied automatically when it's needed. So you got to be careful with that. So that wraps things about irrigation and fertigation. The other thing here is that there's a tile drain. If you have a tile drain here, you just have to tell us what is the depth of tile drain that you have, and then we will adjust the tile, turn on the tile system for you. In many cases, if you have a soil that is not well drained, you have to turn this on, and the farmers, producers know that. Alright, if you have wetland, you're creating the wetland in your field, the model does what it does. It creates area that you'll be designating for the wetland, and also grows the plants within the wetland, which is solely grows in the wetland. So that's the way it affects the nutrients and water and flow and so on in the field by having a wetland in your farm. And if this is the area included in your in the farm, and then you just say yes, and what it does calculate the yield reduction of what you take the land out of the production. It just show you what would be lost if you do this. And if it is outside, you just leave it as outside your boundary of your farm and your area interest, you just say no. So that's going to take care of the wetland. Pond is the same thing. You have depression in your area, in your farm, that water gets collected. All of you need to know what percentage of the land water flows through that depression before it leaves the field. So that's all we need to know. It's the fraction of it. And if you have and then we have stream fencing. This is a little bit more complicated, That means if you have 100 cows that are on your land, and suddenly you fence them and not go into the water body, then we will adjust the model to not have any defecation as a point source from the animals. Also, we change the stream geometry, because now you are doing some changes in by animals stepping on the water, changing in the roughness and so on, in erodibility of the channels. So the other thing is about stream fencing is that if you have the fence part apart from the water bodies, you're basically creating a filter stream. And we will ask you to create a filter strip. Tell us what kind of grasses that you put between that and the edge of the field, edge of the water and the stream. I'm sorry, the fence. And that would take care of as two scenarios now. Not only you are withholding back the animals from going to the water bodies, also you are creating a filter stream. On the grass buffer, forest buffer, is that you will have two options here, is grass buffer and the forest buffer. There are a little bit difference between these two. In the grass buffer, we will ask you what would be the type of vegetation you are growing in that grass buffer, and then also we asking for the width of it. 40 feet, 30 feet, whatever it is. And then also in the area of it, if you do have an area with it, then we will shape that grass buffer, I'm sorry, to a point that can kind of be how shape it is on the edge of the field. If not, we will calculate for you. So it's kind of optional, the area optional. So the other thing you need to have to say, the fraction of the field treated by buffer means basically if you have 100, let's just put this example, 100 gallons of water passing through this grass buffers, is all of them pass through or just some of it goes around it? So basically we're talking about the grass buffer efficiency, and if it is 1, it means everything goes through it. You have to just set it as 1. Again, here we're asking you if you took the piece of land and you dedicated to the grass buffer or forest buffer, or is just outside your land. So that's just for calculation of the crop yield and modifying it. So if you do have forest buffer, in this case it's a similar thing. We don't ask you anymore for grass. In the forest buffer, there typically sometimes there is a grassy area, and then you just go from the grassy area to the grassy area with the trees growing together. So we simulate this as a two separate fields. And if you don't have the grass area, if you say 0, then we will have just the trees and the grass, and we will simulate that by giving a default management file that is going to be the trees, and also is going to be the grass is going to be summer grass. So that is being simulated for you, but again you have to give us the efficiency of the system. If everything goes through it, then you have as 1 as 100%, and if it is fraction of it, you have to give us a fraction. Alright, so the next item is going to be the grass waterway. In this case, in grass waterway also we ask you these are what is going to be the grass is growing, and also the width of them and the efficiency. That's all we need to ask from you. These are different from the filter strip, which is the edge of the field. This is within the field, as you know. So this is going to be a little bit different. The next items that we will be looking at here is going to be contour buffer, and the contour buffer are very unique. In NTT, contour buffer are not being simulated as a lookup table, and says if you have that's going to be the reduction in the nutrients and sediment. So we actually simulate that. And how do we do that? Is that you give us the grass buffer, the let's say the crop that you are growing in that grass buffer is going to be alfalfa, for example, or any of this. Let's say we are going to broom grass. So if the broom grass is growing between the corn, we know your major crops is corn here. So you go grow the broom grass between the corn strips. So you need to know what's the width of the strips from corn and what is the width of a strip from this broom grass at this case, in this example. And then what the NTT does, it does split your fields to different section, and the water and nutrients gets routed from the cornfield to the broom grass, in this case field, and then go on and go on. So this is the way you are filtering the sediments and nutrients before it gets to the edge of the field. Alright, then we have the land leveling, and that's a slope. If in many cases, like in Mississippi, they because soil is so loose, they cannot afford any kind of slope, so they kind of flat the field. So we just adjust your slope and the slope length once you adjust the field slope, and then we will just simulate it as changing the land leveling. And the last thing is that it's going to be terrace system. If you just have it, just turn it on. This is the only scenario that looks up a table. Means that if you have, depending what the slope of the land is, we will adjust the management factor, which is part of the erosion equation, and then we adjust the erosion, and consequently with that is going to be nutrient adjustment. So basically these are some of the major constructional BMPs or conservation practices that's happening out there. We have incorporated, and this is additional to all those scenarios you can simulate as cultural practices in the previous page. So after you're done with it, save and control. So you are ready to simulate now. So you have scenario 1, which is your baseline. So we can go ahead and create scenario B and C and so on. So let's do that. Let's just go ahead and create another scenario. So if I want to add another scenario, I'm says add new scenario, and I'm gonna say this let's say nutrient reduction, or so what I'm going to do here, and maybe I just that should be good. So I'm going to save this, and it's going to ask me again what crop I have. Add crop rotation. I'm going to go the same thing as corn before, year 1, upload. But with this case, I'm going to reduce my nitrogen to half to see what happens. So I'm going to go ahead and change the nitrogen amount from 180 to maybe 100, and save this. So now you see under this scenario my nutrient management is changed. Now I don't apply 180, I apply 100. So I don't put any kind of structural BMPs, and I just say continue, and save and continue. Now I have 2 scenarios, and if you see these green dashes, means that you have done well. But simulation is not done, that's why you don't get any date. So if I want to simulate both, I just go ahead and click this button and then select it for me. So all I have to do the simulation. So what happens, the information that I gather through the databases and the one that user puts as an input is all collected, goes to an apex in the cloud, and simulate them for all these 3 soils within the farm, and average them, and then bring back the results to me. That's why it takes a little bit of time, but nevertheless we have to wait till that shows up. So that you see that the date in here is changed. That means when the date is changed, that means you have simulated your scenarios. So I want to see what these scenarios have done for me. So I go to results. Under results, I have 3 options in the tabular form, and then in a graphic which is annual and also monthly. So what I'm going to do, I can compare 3 scenarios at a time. I do have a baseline. I have just 2, as remember. So the other one is nutrient reduction, but I don't have the 3rd one. So then I can see the result per unit area, let's say per acre and so on, and then also I can see the result for total area, my choice. And so once I do that, I say the review of these results. So you can see the 3 different colors columns, that this one is for baseline, and this is for alternative, and this is for the second alternative. So what am I going to see here? It shows me the losses of nitrogen, and it's a very flat field, doesn't have much, and also phosphorus, and also the flow and yield and the stresses. So I'm going to go through this, which is very important to cover this, and then we look at the graphic a little bit, and then we just see where we go from there. So if I want to see the results more detail of what is total nitrogen, these are surface and tile system. Form of the nitrogen lost the field is in the organic, can be organic, it could be a soluble, it could be subsurface coming through lateral, and the tile drain system. I didn't have a tile system, so I don't expect to see anything, but these are the factors happening. So when I reduced, I get to see more of organic N, and that means because probably I think we had more erosion, because there's less residue available in the surface when the crop yield is lower, and I'm positive that we have crop yield is lower. So let's just turn on the crop yield. So in this case, yes, you see that it's from 159 bushels to came to 104 bushels because I cut off the nitrogen. And therefore, if I go turn on the phosphorus also, I probably expect to see organic P has gone up too, yeah, because the organics are attached to sediment. So it makes sense to me. This results is okay. The other type of information I can get is also how much was N2O to the atmosphere under different scenarios, and leaching, how much was leached into the system. Because there's more nitrogen available here, of course there's going to be more leaching, and also there's not much of N2O losses in here with the lower nitrogen because there's not much of nitrogen. So everything reasonably makes sense. So the question is also is that if I have subsurface tile drain, it tells me how much was surface, how much. So it's kind of splitting this flow that I have, that how much was in the different form from my field. And other water, if I had irrigation, I would have the numbers showing up, how much I irrigated, and then the deep percolation, how much went the deep percolation. However, I would like to get your attention to something very important here, and that's very unique in NTT. So we have a stress levels, correct? And if I am not in optimum yield, according to what I usually get in the these are again the last 30 plus years of simulation. It doesn't mean dry and wet years. So if I don't get my average, then I want to know why. And let me, before I do that, there is another thing here. Is in the parentheses, the number you see in the parentheses are the confidence interval. So it shows basically it's based on the dry and wet years. So if there's 0 means every year was the same but if definitely there's no zero, so there's going to be changes in the weather from one year to another, so these numbers vary. So let me see, what am I doing that is not, am I on optimum? So if I have no an interest and a stress level, yes, you see that about on the regular application of 180, I am about 15% stress level. On the 100 pounds of application, I'm at 35. So definitely nitrogen is very important, and even in a baseline I can apply more nitrogen, maybe 200 pounds, not more, I don't think so, but that's going to show me. So am I having a P stress? I don't think so. I believe that 60 pounds of the pure N is pure P, soluble P is too much. It's typically 20-30, and this model can show you how much you can save by playing around and reduce your phosphorus to a 20-30, see if it does sufficient. And then if this value, if shows zero stress, that means you're doing fine. It's a very, very significant table here. So temperature stress is basically is, you know, it's not much we can do about unless you change the data planning and play around with it, but you're always going to have a temperature stress. But the water stress, if I needed irrigation, it would show me that I am stressed by the water. So these are the kind of 4 items here you can adjust to optimize your crop yield. And when you optimize your crop yield without excessing the use of nitrogen and water, you will also help environment because you create enough residue to cover your ground, and then less erosion happens from there. So this is a table that looks at tabular, and then you go to the annual values, then you can do graph it. So I have these 2 scenarios, and I guess I told you as I before we can have the 3rd scenario too to compare. So in this case I can look at the flow, nutrient losses, phosphorus losses, erosion, and crop yield. So in any of those cases, for example, I can look at the different type of flow, so it gives you all the details you want. Say we're going to be surface flow, so view of that, and shows you under which scenario we had more flow. Of course, because in this case you had less residue and less crop to uptake the water and prevent the runoff, so that makes sense. So also I can look at the monthly charts and look at nutrient reduction scenarios and the baseline, and also I can go ahead and say organic N, organic P, or whatever those, let's say PO4, let's say nitrate, organic N, I'm sorry. Let's look at that. So you see that the organic N is the higher than the baseline because of sediment loss more. But also this shows you what part of the season, of what month of the season you have to pay attention to your area of interest, because that's where the rainfall and crop activity is happening the most, which makes sense. This is a time in Ohio they get the rain and the crop growth. So this basically will tell you what you are able to observe as the results. And then we have also utility file. This is not available in the basic, which is not needed for basic version, and that is talks about, you know, parameters. So for researchers, they can change the params, control files, and sub area, soils and operation and site file, which are the major parts of this files for the Apex, and see the results, and they can optimize the parameters for the area of interest. So this is basically for the research and education. The field routing, this is the watershed function of this program, which I will be talking about that in the next series that coming up soon on the videos, and I will show you how you can use this as NTT as a watershed model, And if you have multiple field or multiple sub-basin, you can use this function and do the simulation at that scale. Well, with that, I would like to again get your attention to contact us in the case you need some help. And also you can have the page instructions is going to come up at any page that you are in and help you to walk through it. And also some FAQ and then help. They're all available to you. And then also the languages. We will have this program as the G2 version is available right now in Spanish and English, so the people can use in the both languages. Again, thank you so much for your attention. I hope this was helpful to you. Again, we are always at access to you by any means, by email and by through this site.